Hi, my name's Xiong Chang, and I'm the co-founder and CEO of Tensorfield Agriculture. We help farmers grow more with less, up to 40x less manual labor and 10x less applicant via robotic microspray solutions. Quick context slide. This is the latest prototype that we are field testing, and it's a microspray robot built for specialty crops. We're in the process of running trials here in California, predominantly on densely planted vegetables such as carrots and baby leaves. Bit of background about the team. This is Team Tensorfield, and we work out of Union City in the San Francisco Bay Area. We have a uniquely broad range of engineering experience as a team of technical co-founders from Stanford, Cambridge, and Imperial College. I'm Seong. I studied manufacturing engineering at the University of Cambridge, and I look after biz dev and mechanical engineering, having led global teams in the past as a product owner. Chihan is our CTO, and for the last 9 years has focused on real-time computer vision, video compression, and machine learning. Sandeep used to run the mobile group technical office at Broadcom and looks after our robotics and electronics stack, while Louise is our mechatronics engineer with a farming and agricultural background. Founded in 2018, we have a strong network of key backers, having received investment from 3 venture capital funds: SVG Ventures via the Thrive program, SOSV Venture Capital, and Morado Venture Partners. We're currently participating in the Alchemist Accelerator too, and we count Tom Shields, venture partner at AgFunder, as one of our early investors. As we know, certain practices in the application of herbicides, such as repeated single modes of action and improper dosing, are leading to increased numbers of herbicide-resistant weed species. Labour is also extremely scarce, and increasingly so, meaning hand weeding is not economically viable. We aim to address this problem by revolutionising the way that we spray applicants and adding a thermal mode of action to replace herbicides where possible. The existing solutions out there aimed at tackling post-emergent weeds against the crop canopy don't currently provide a complete solution. They either lack the precision required for dense canopies, require specific build configurations for each crop seeding arrangement, or rely on mechanisms that don't treat undersurface growth. With our microspray technology, we add a thermal mode of action to the toolkit for growers, while adding the ability to very precisely dose applicants just to the plants that require it. Our USP is plant-level action, not just plant-level data. We can apply with half-inch precision the right amount of foliar feed or biostimulant to only the plants that need it, or a precise thermal shock or dose of herbicide to kill weeds on site. Our first product will be a thermal weeding service, which addresses the most immediate pain point for our leafy greens growers, who spend millions on hand weeding every year. Weeds are dosed with heated, food-grade canola oil, and the damage to their meristematic cells prevents regrowth, leaving the crops to flourish. We also have the potential to precisely dose systemic or contact herbicides using the same technology stack that we've built up. We're excited about the potential use of this technology in cases where undersurface growth is occurring, for example, targeting yellow nutsedge or potato volunteers against the crop canopy. The alternative is unaffordable hand labour or broadcast herbicide application that would lead to unacceptable crop damage and high applicant costs. So how does it work? We've designed a spray system from the ground up that can spray exactly where our target is, with 10x greater precision than the nearest competitor. Our first product leverages this technology and combines it with a thermal mode of action to spray heated vegetable oil at weeds, killing them without costly hand labour. You can compare the competitor spray cells on the left with the centimetre level resolution that our spray system affords on the right. We use canola oil as it's plentiful, inert, and heats much faster than water into a higher temperature in order to transfer energy to the target. It offers excellent surface adhesion to plant tissues and is organic approved by the CCOF. Killing weeds with heated vegetable oil isn't new, by the way. It was successfully trialled in processing tomatoes by UC Davis back in 2012 and efficacy tested against a range of weeds by the University of Bonn in 2017. A sister study at Bonn also confirms the rapid mineralization of the oil within weeks of application. Here's a demo of our heated sprayer in action with dummy bulbs placed at 3-inch spacings on a tray for scale. At full speed, you can get a sense of how quickly our rapid targeting system performs. When slowed down to an 8th speed, we should get a much clearer picture of what's going on with respect to droplet formation and surface adhesion. When we superimpose a thermal image of the tray after treatment, we can see the heat map showing where the thermal energy has been deposited, leaving the dummy bulbs untouched. We've built and trained our own detection models from scratch, with Chihan's experience in his prior roles to detect crops and weeds in real time for accurate targeting here on a customer site, one of the largest carrot growers in the world. The small robot you see, named Snappy, is a lightweight scouting device that we've been using solely for image acquisition. This is V2 of our robot, which we built after getting feedback from our customers on the initial data collector shown earlier. We ran a pilot study for this customer and found the deployment of just 6 robots would see cost savings of $3 million per year at today's labor costs. Each of these units, running at 2 km per hour, kills weeds at the rate of a whole crew of 40 hand laborers. It's the unit economics of this technology that has made it such a compelling case for our venture capital investors. If we look at the landscape of competitive weeding technologies, we combine the very high spatial resolution afforded by lasers with the efficacy of spray solutions, whether via thermal shock or herbicidal modes of action, to cover all bases. Note that our sprayer has a universal design which covers the entirety of an 80-inch bed top at present, so no physical reconfiguration is required when moving between different seed line arrangements. Due to its modular design, our spray system can also be adapted to cover as wide or as small an area as possible when considering scaling to crops with greater acreage. It's certainly an exciting time to be in this space, and we consider ourselves leaders in microspray technology and currently in the process of filing several patents. Though based in the Bay Area, you can also find us as residents at the Western Growers Center for Innovation and Technology down in Salinas. We have service agreements signed with some of the largest growers of organic vegetables in the US. We were also Thrive participants and finalists in the 2019 Robotics Challenge run by the Agro Innovation Lab in Vienna. Please reach out to me if you're interested in collaboration or would like to hear more about our solutions offered. Thank you for your time and attention in hearing about Tensorfield agriculture.